Fourier transform. See, we have in Fourier series x of n equal to 1 by 2 minus t by 2 to t by 2 to x of t e power minus j n omega naught t dt. Omega naught is 2 pi f naught. And taking this to this side, and what is Fourier transform is extension of Fourier series to aperiodic signals. Aperiodic signals are periodic, but their period is infinity. So t is 0, t is infinity, f naught equal to 1 by t equal to 0, n equal to many values. So in n f naught tends to, f naught is going to 0, n is going to infinity, then n f naught tends to some finite value f, that is 2 pi n f naught equal to 2 pi f equal to omega, that is n omega naught equal to omega in Fourier transform. X of omega equal to x of j omega equal to minus infinity to infinity x of t e power minus j omega t dt. If you want to get again back x of t, inverse Fourier transform, x of t equal to 1 by 2 pi minus infinity to infinity x of omega e power j omega t d omega. Here plus it is omega domain, it is f domain. X of f equal to minus infinity to infinity x of f e power minus j, in place of omega write 2 pi f t dt. If we want to get x of t from x of f minus infinity to infinity x of f e power j 2 pi f t df. And Dirichlet conditions are necessary for the Fourier transform to exist. What are Dirichlet conditions? X of t must be absolute integral. X of t absolute integral means minus infinity to infinity x of t modulus of x of t dt should be finite. X of omega should be finite, that is excitation. X of t should not have any discontinuities, even if it has total discontinuities, or if it has discontinuity must be finite, and the amplitude of the discontinuity must also be finite, that is it should not be infinite. See, here you have some examples. First we have u of t. U of t is first not satisfying first property, that is it not absolute integral, but second property it does not have any discontinuities. One property is satisfying. Dirichlet conditions are sufficient conditions. One is an example for existence. For impulse, first property area absolute integral, okay, satisfying. Second property, it has a discontinuity, amplitude is equal to infinity, t equal to 0. One property is enough. So this also has to satisfy two properties. This satisfies one property. Tan t does not satisfy any property, so it does not exist Fourier transform. Now we have e power minus at u of t Fourier transform, and this derivation e power minus at u of t Fourier transform 1 by a plus j omega. E power minus at u of t Laplace transform is a plus f. Laplace transform is nothing but s equal to j omega. U of t Laplace transform is 1 by s. But u of t Laplace Fourier transform is not 1 by j omega, but because we have this real but we should get here here complex signal, but you have only we have got only imaginary signal. So u of t Fourier transform is not 1 by j omega, it has some extension. U of t Fourier transform is 1 by j omega plus pi impulse of omega. X of t impulse of t Fourier transform is 1. We have the rect to t Fourier transform is 2 by omega sin omega by t over sin f, and rect to t and sin f are dual functions. This is duality theorem. Duality theorem is very important. X of t Fourier transform is x of omega, means capital X of omega means capital X of t Fourier transform is 2 pi x of minus omega. X of t Fourier transform is capital X of omega f, means capital X of t Fourier transform is x of minus f, small x of minus f. This is duality theorem. From that we can e power minus at u of t means 1 by a plus omega, then 1 by a plus jt Fourier transform is 2 pi e power a omega by u of minus omega. To get Fourier transform, first apply standard integration. If that fails, then apply duality. So from duality we get sin t Fourier transform as rect to f. From we know rect to t Fourier transform is 2 by omega sin omega by 2. From that 2 by 2 sin t by 2 equal to 2 by rect to omega. These are the some properties. In linearity properties common in all. Time shifting property, x of t minus t naught equal to e power minus j omega t naught x of omega. Time scaling property, x of at equal to 1 by a x of omega by a. This is in time scaling in frequency domain. X of a omega equal to 1 by a x of t by a. Time reversal, x of minus t equal to x of minus omega. Always write in terms of rect to get Fourier transform, and write in terms of u of t to get Laplace transform. And we have this very important e power minus a mod t Fourier transform as 2a by a square plus omega square. Time differentiation property d by dt of x of t equal to j omega x of omega. Time integration property minus infinity to infinity x of t dt 1 by j omega x of omega by x of 0 impulse of omega. We derive step function Fourier transform from this only. One Fourier transform is 2 pi impulse of omega, or 1 Fourier transform impulse of f. So this is the derivation of a step function Fourier transform. And we have signum t Fourier transform is 2 by j omega. 1 by pi t Fourier transform is minus j sgn of omega. If x of t is converted with 1 by pi t, we get Hilbert transform. Hilbert transform is not a transformation technique. And we have frequency shifting property. X of omega minus omega not equal to e power here sign change here minus so plus e power j omega naught t x of t. X of omega plus omega naught equal to e power minus j omega naught t x of t. Similarly, we have cos omega t x of t equal to 1 by 2 x of omega minus omega naught plus omega naught. Sin omega t x of t equal to 1 by 2 pi j x of omega minus omega naught plus x of omega plus omega naught. Minus for cos here plus, for sin here minus, for sin extra multiplied with 1 by j. We have one Fourier transform as 2 pi impulse of omega. Then if frequency shifting minus impulse of omega minus omega naught means here plus e power j omega naught t. Here plus means here minus. Similarly, we are writing cos omega naught t Fourier transform is pi by impulse of omega minus omega naught plus impulse of omega plus omega naught. Sin omega naught equal to pi by j impulse of omega minus omega naught minus impulse of minus omega plus omega naught. Time frequency differentiation property d by d omega of x of omega equal to minus jt x of f. Frequency integration property equal to minus 1 by jt x of t. Time convolution, if they are convolved in time duration, they are multiplied in frequency domain. When two signals are multiplied, always applies frequency property. That is, if multiplied with the periodic signal, frequency shifting. Multiplied with the frequency, if multiplied with 1 by t, frequency integration. If they are multiplied, frequency convolution. And this is very important. Calculation of output given input and h of t and impulse of t. If x of t is sinusoidal periodic, apply the a1 a2 formula. If x of t is non-sinusoidal periodic, apply Fourier series convert to sinusoidal periodic and then apply a1 a2 formula. Here what is magnitude spectrum will give energy or power in the signal, so we consider mostly magnitude spectrum in communication system. From space spectrum, the symmetry in the signal can be understood. Half wave symmetry returns odd harmonics. To return even harmonics, this should be plus. To return odd harmonics, this should be minus.